Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE chemistry bond energies. So last time we did a chemistry video, we were talking a bit about the energy changes, how certain reactions release energy and therefore they're called exothermic, and certain reactions actually require energy input. They need to uptake some energy from their surroundings and therefore they are called endothermic reactions. So we talked about that a bit last time, and now we will be going into why. We'll be going into why this happens. So this all happens because of changes in energies contained in bonds. As we briefly discussed previously, the energy tends to be contained within the bonds, and the changes in the bond makeup will lead to overall changes in energy. So, without further ado, let's get started. So, because energy is contained in bonds, therefore there are two main rules to remember when it comes to this topic, guys. At first, bond breaking is endothermic. Bond breaking requires energy. I mean, this kind of makes sense if you think about reactions, and if you think about the fact that most of reactions happen for a reason to achieve the most favorable bond formation. So, bond forming is exothermic and bond breaking is endothermic. So, bond breaking actually requires energy. And that, again, if you think again about it, also another reason why it makes sense is because if you start ripping things apart, you need energy to rip things apart. And bond forming usually happens because of charge differences or because of more favorable energy state. So bond forming is exothermic. It actually releases energy when those molecules attract each other to form a bond. So, bond forming, exothermic, bond breaking, endothermic. And so this is the theory, this is the main theory about bond energies, but today the bulk of the lesson will be how to calculate those changes in energy. Knowing how individual bonds behave in a reaction can give us a way to calculate the net energy change, and therefore we can determine whether a given reaction is exothermic or endothermic. Now, the main equation to remember here is right here. So energy change is equal to energy required to break bonds minus energy released by forming bonds. And so this may become a bit tricky later on, but don't worry, I will explain everything step by step and it will all make sense to you by the end of the video. But that's the energy change required. It's a difference between energy required to break bonds and energy released by forming bonds. And the order here is important. That's one thing that we need to remember here. The order, that first we have energy required to break bonds and then energy released by forming bonds is second. And that's the difference. So you will see how it all comes together in a second, how all of that basically works. Okay, so here I prepared an example because I think this is actually one of those topics where the best way to learn this is simply by example. So, bond energy calculations. Here we have an example. Hydrogen plus chlorine gives you 2HCl, hydrochloric acid. So hydrogen plus chlorine gives you 2HCl. And before we go any further, we need to look at what happens. What happens in terms of bonds? So I drew this out right here. So we have one bond of hydrogen to hydrogen, one bond of chlorine to chlorine, and then they react to change their bond makeup. They change into hydrogen-chlorine bonds, two hydrogen-chlorine bonds. So we start with one hydrogen-hydrogen bond, one chlorine-chlorine bond, and then we end with two hydrogen-chlorine bonds. Now, each bond that you will come across, each and every single bond, will have that energy contained. As we discussed, bonds contain energy within themselves. So, as you can see right here, each bond type will have a specific energy amount contained. So, hydrogen-hydrogen bond will have 436 kilojoules per mole. Chlorine-chlorine bond will have 242 kilojoules per mole, and hydrogen-chlorine bond will have 431 kilojoules per mole. And that will stay constant for those bond types. That will stay constant. And of course, if you have double bonds and things like that, things change. But for that specific bond type, that energy will stay constant. And again, don't worry, you don't have to remember these values for every single bond that is out there. Don't worry, that will usually be provided to you in the exam whenever you have to answer a particular question. So, how do we do this? So, the aim here is to calculate the energy change, the net energy change of this reaction. And then we will determine whether that reaction is endothermic or whether it's actually exothermic. So, what happens here? First of all, we need to calculate energy required to break bonds, as the equation says. And how do we do this? Well, what are we breaking? We are breaking one hydrogen-hydrogen bond, we are breaking one chlorine-chlorine bond. And so, using these values, we are adding 436 kilojoules per mole plus 242 kilojoules per mole, which gives you 678 kilojoules per mole. So that's the energy that's actually required to break those bonds. That's the energy that goes in from the surrounding. But now, we need to move on to step 2, which is energy released by forming new bonds. And what bonds are we just forming? So we have just formed 2 times hydrogen-chlorine bonds. So those guys here. So, as we can see here, 431 kilojoules per mole. That's the sort of energy contained in a single bond like that per mole. And right here, we would do 2 times 431, because 2 of those, and that's equal to 862 kilojoules per mole. So now we have 2 important values. We have a value for energy required to basically break those bonds, and we have a value for energy released to form these new bonds. And now we just plug those 2 values into the equation. Net energy change, I abbreviated it here slightly, but you can see if you skip back, I showed you the whole equation. But here we have net energy change, which is equal to energy from breaking energy required to break bonds minus energy required to form bonds. So we simply plug in those values. Energy required to break bonds right there, 678 kilojoules per mole, minus 862 kilojoules per mole from here, and that is equal to minus 184 kilojoules per mole. So there we go, that's our net energy change. However, what does that mean? So we actually ended up with a negative value. And what does it mean in this context? So let's go back. So when we have energy required to break bonds, we put in 678 kilojoules per mole. And we have gained from this reaction 862 kilojoules per mole. So essentially, we have released more energy than we put in. So by that logic, we can see that this reaction must be exothermic. So that makes sense so far. However, we are ending up with a negative value. So that actually is okay. That's exothermic reactions will always give you negative net energy change. They will always give you negative values, and that's just the way it is. Now, why would we design this equation in such a way that we get negative values? Why not have positive values for exothermic reactions and negative values for endothermic reactions, which would kind of be intuitive? Well, this is because these values essentially represent, you can kind of think of these values as energy contained in those bonds. So we can sort of think when we're breaking those bonds, we have sort of 678 kilojoules per mole trapped in them, and then when we break the bonds, we release 862 kilojoules per mole. So we are releasing 184 kilojoules per mole. We don't have all of that trapped in those bonds anymore. So the value is negative because it's energy release. We are losing that energy from the system. It's not trapped inside the bonds anymore. It's released, which is why the value is negative. That's the way I like to think about this. And that's important because, and that again comes down here why the order is important. If you flip these, if you put form bonds here at the beginning and breaking bonds at the end, if you flip the order of the equation, then of course you are going to get the wrong value. You are going to get a positive value, and that will be the wrong answer. So this is why it's important to have the correct order of the equation and to know what the negative value means and what positive value means. Negative means exothermic, positive means endothermic. So this is it for today, guys. Thank you very much for watching my videos. I really appreciate this. This is why I do this. So you guys watch it, and hopefully, I really hope this video helped you. If you think this video helped you, give me a thumbs up. If you have any questions, any queries whatsoever, just pop me a question on comments. I will try to get back to you as soon as possible. And if you're interested in more videos like this, looking at maths, GCSE maths, A-level science, GCSE science, and some biomedical science videos here and there, hit the subscribe button below. Don't be shy. Thank you again for watching, and see you next time.